Okay, in this screencast, we'll continue our work on hypothesis testing for proportions. So in hypothesis testing, you're choosing between two different realities, two possible versions of reality. One is called the null hypothesis. There's nothing going on here, there's no difference, meaning, this drug has no effect, or this ad campaign doesn't boost sales, whatever, there's nothing going on. And when we do hypothesis testing, it always includes an equal sign for the null hypothesis. And the alternative hypothesis is whatever it's competing with. So in our polling example, the null hypothesis, which we write H0, was that P, the proportion planning to vote for a candidate, was 0.5, and the alternative, P greater than 0.5. We wanted to know, do we have evidence that P is greater than 0.5? That's the alternative. And the nothing going on is that P equals 0.5. It's a tied race. And depending what our research question would be, the alternative could be less than or it could be not equal. So it just depends upon what it is we're interested in, what the alternatives really are. So there's 5 steps to hypothesis testing. 1, we state the null and alternative hypotheses. 2, we compute the p-value. In our class, we do this using technology. 3, we make a decision to reject or not reject the null hypothesis. So reject means, okay, the null is not right, we think the alternative is. We have evidence for the alternative. And we usually ordinarily reject if the p-value is less than 0.05. But for real researchers, it sort of depends on the costs and benefits. The p-value, remember, tells you how likely the data you just got would be if the null hypothesis is correct. That's what a p-value is all about. The probability of getting the data you got if the null hypothesis is correct. Then you have to state your conclusion in plain everyday English and explain why the p-value leads to that conclusion. So for example, in our candidate example, the null was p equals 0.5, the alternative was p greater than 0.5. Our p-value, not little p proportion, but capital P, p-value, which is the probability of getting the 0.52 we got if the actual proportion was 0.5, the p-value was 0.10. Well, that's not less than 0.05. That's not small, so we don't reject the null hypothesis. When you don't reject, that means, well, maybe the null is true. We don't have evidence that the null is false. So the conclusion is we do not have evidence that our candidate is winning, because if the race is tied, there would be a 0.10 or 10% probability of getting a sample proportion of 0.52 or higher. So the data we observe would not be that surprising. And there's a very similar procedure to compare two population proportions. So the research question, is the proportion of men with health insurance the same as the proportion of women with health insurance? If you look at our health data, you'll see that 460 of 522 women had health insurance, 398 of 478 men had health insurance. And what we're interested in is the proportion of women compared to the proportion of men. So we change to proportions and then enter it into Excel. So for the women, population 1, the sample size was 522, and that proportion turned out to be 0.88 when we change our raw numbers into a proportion. For men, 478, and the proportion is 0.83. So these two proportions in our samples are different. 0.88 is not the same as 0.83, but does that mean that in the population as a whole they're different? Is that difference that we see here between the 0.88 and the 0.83, is that difference statistically significant? Well, the alternative was not equal in this case. We just want to know are they the same or not the same. And we see 0.028, which is statistically significant. If we go through all 5 steps, the null is that the proportion of women is equal to the proportion of men. The alternative is that they're not equal because of the way the question, original research question, was worded. The p-value, here it is again, 0.028, that's the one that goes with the not equal. P-value is 0.028, so that's statistically significant, that's less than 0.05, so we reject the null hypothesis. We say, I think the null is wrong, I've got evidence that the alternative is true. So conclusion is we have evidence that the proportion of men and women who have health insurance are not the same. And then why did the p-value lead to that conclusion? If men and women had health insurance in the same proportion as each other, if the two proportions were the same, there'd only be a 0.028 probability of getting sample proportions as far away from each other as we got with these sample sizes. So our observed data would be unlikely to happen due to chance. So this is the observed data. This is what we got when we looked at a sample of 1,000 people, 522 women, 478 men. If the proportion of each that had health insurance were the same, then getting numbers this far apart would be very unlikely. Getting proportions this far apart would be very unlikely. And so therefore we conclude that the proportions are not the same.